Hi students, in this chapter we're learning about solving linear systems. The last section we learned about solving linear systems by substitution. Here we're going to work on solving linear systems by combinations. So there are steps that you need to follow when you go about solving linear systems using combinations. Step 1. What you're going to do is you're going to arrange the equations with like terms. You're going to line them up in columns, normally in the form of ax plus by equals c. That's going to help you. So line it up with like terms in the columns, ax plus by equals c. Step 2, you're going to multiply one or both of the equations by a number if needed. You'll see why I say if needed here in the examples coming up, to obtain coefficients that are opposite for one of the variables. Step 3, you're going to add the equations from step 2 by combining like terms. And this is going to eliminate one of the variables. And then you're going to solve the remaining variable. Step 4, substitute the value attained in step 3 into either of the original equations to solve for the other variable. And then step 5, you're just going to check your work by plugging in your solution into the original equations. So let's work on solving systems of equations looking at combinations. Step 1, we want to line up the equations in the ax plus by equals c form. Is this lined up in the ax plus by equals c? It is. You have negative x plus 2y equals negative 8, x plus 6y equals negative 16. Then what we have to do is we have to look at the x's, you have to look at the y's, and you have to see which one can just eliminate, meaning can negative x plus x, can that give you 0? It can. When you add 2y and 6y, does that give you 0? It doesn't. So notice how the x, negative x and positive x become a 0. That's going to cancel. So what I do now is I add my 2y plus my 6y, and I'm going to get 8y equals negative 8 minus 16 gives me negative 24. So you're adding the columns. So this gives me negative 24. So I've eliminated x, I've added the y's. I'm going to now solve for y. So I'm going to divide 8 to both sides. So I have y equals negative 24 divided by 8 is going to give me negative 3. I have solved for y but not x. So what I need to do now is go back to one of the two. It doesn't matter which one you choose. And you now need to solve for my x. So doesn't matter. Let's work with the bottom number because my x is positive. So we have here x plus 6y. My y is negative 3 equals negative 16. So we have here x plus negative 6 times negative 3 gives me negative 18 equals negative 16. I'm going to add 18 to both sides to solve for my x. And I'm going to get x equals negative 16 plus 18 is going to give me positive 2. So what I got here is x is going to be 2. I'm writing this as an ordered pair. Y is negative 3. Now how do I know if this is a solution or not? What I do now, this is my last step, step 5, I check my work by plugging in 2x for 2, negative 3 for y to make sure it equals negative 8 and negative 16. So here we have negative x, so that's negative 2 plus 2 times y is negative 3. Does that give me negative 8? Well, negative 2 minus, negative 2 plus negative 6, that gives me negative 8, that checks. X here, we have 2 plus 6 times my y, which is negative 3. Does that give me negative 16? Well, it's 2 plus a negative 18, and that gives me 16, so that checks itself out. So that's how you go about solving these kind of problems. Now let's look at example number 2 here. We're solving this linear system. Do the x's line up? Yes. Do the y's line up? Yes, they do, and so do the numbers standing alone. But here's what's different, is we can't automatically cancel the x's because 2 plus 3 does not cancel to be 0. -3 and -2 do not cancel to be 0. So I need to multiply my top equation and my bottom equation by a number to either cancel out the x's or the y's. I'm going to cancel out the x's. So what I'm going to do is we need to have one be positive 6, one be negative 6. 2 times 3 is positive 6. 3 times -2 is -6. When I'm multiplying the top equation and bottom equation by these numbers, you need to multiply it by each situation in the equation here. So 3 times 2x gives me 6x. 3 times -3y gives me a -9y. 3 times 0 equals 0. -2 times 3 gives me -6. Now those x's will cancel, but let's continue with this. -2 times -2y will give me a positive 4y. -2 times positive 5 gives me -10. Now I line up. What can cancel? My 6x and my -6x. Those become 0. So now I add -9 plus 4 gives me -5y, and then 0 plus -10 gives me -10. Divide -5 to both sides, so y equals 2. I've solved for y. Now I choose one of my original equations to solve for my x. You can work with one of the originals up here. Doesn't matter which one. So here we have, I'll choose the first one. 2 times x minus 3 times 2 does equal to 0. Let's solve for x. 2x, -3 times 2 gives me -6. I'm going to add 6 to both sides. 2x equals 6, and I'm solving for x by dividing 2 to each side. So x is going to give me a value of 3. I've solved for my x and my y, so my x value is 3, my y value is 2. So now to check this, I plug those values into the original to see if it equals 0 and 5. 2 times 3 minus 3 times 2, that is 6 minus 6. Does that give me 0? It does. It checks itself out. Second equation, 3 times x, 3 times 3, minus 2 times 2, does that give me 5? 9 minus 4, that gives me 5, and it checks itself out. So this is my answer for that. Last example here. So this is a little different from the first two that we solved. Here we have 3x minus 6y plus 12. And we have -x plus 3y equals 6. Do these line up? Do the variables line up? Are they in the form of ax plus by equals c? They are not. So we need to put them in that form. The first one, 3x equals -6y plus 12. I want to get it in the ax plus by equals c form. So I'm going to add 6y to both sides. So what I'm going to have is 3x plus 6y equals 12. Now it's in that form, and the bottom equation is in that form already, so we'll just write it down below. -x plus 3y equals 6. Now, my x's and y's are lined up. My numbers, my constant numbers are lined up as well, but nothing automatically cancels. My x's don't automatically cancel, or y's don't. What I'm going to do is I'm going to just multiply the bottom equation by 3. Because then I can cancel out my x's. So let me rewrite this. I'll take all of this and rewrite it over here. So we have 3x plus 6y equals 12. Remember, we have to multiply this 3 to each situation. So 3 times -x gives me -3x. 3 times 3y is going to give me 9y. 3 times 6 is going to give me 18. So now everything's lined up, I can cancel the x's, that becomes 0. 6y plus 9y is going to give me 15y equal to 12, and 18 is going to give me 30. Divide 15 to both sides. So my y is going to give me the value of 2. Now I solve for x. I choose one of the original, doesn't matter which one. I'll just go ahead and put it in with the first equation. So we have 3x equals negative 6 times 2, which is, times y, I'm sorry, which is 2. So negative 6 times 2 plus 12. We have 3x equals negative 12 plus 12, which gives me 0. So 3x equals 0. We got to get x by itself, so divide 3 to both sides, and x is going to equal 0. So my answer, my ordered pair, the solution here is going to be 0, 2. And then I can check that by plugging that in. So here, I'll put my check step at the bottom. So we have here 3 times x is 0 equals negative 6 times 2 is y plus 12. 0 equals 0. That's a true situation. The next one, negative x, so that's negative 0, which is 0. So you have 3 times 2. Does that equal 6? It does. 3 times 2 is 6. That equals 6. So that is my answer, and those are the steps to solve this.